Okay, good afternoon, everybody. Normally I like to walk around, but I have no clicker today, so I'll be coming back to the computer. My name is Andres Cartagena, and I work for MFL Group. MFL Group, for some of you, it's already a familiar company, but just to clarify it, MFL Group is a machine manufacturer with 128 years of history. We manufacture from the drawing machines all the way to the extrusion lines. As Achilles explained, I wear many hats at MFL Group. The first one is I head the MFLX division, which is a special division that works as a tech company inside a mature machine manufacturer. My second hat is as head of MFL Care, which is the division that takes care of the after-sales activities, spare parts, managing all the commissioning of machinery, repairs, all the problems that arise after the machine have been commissioned. And as you may imagine, the technology part and the services part are highly correlated. The other hat that it was not mentioned, but it's important, is that the owners of MFL Group have an investment fund, and we started investing in high-tech companies that operate in the industrial sector about 5 years ago. And we do these investments in an early stage, and then we work with them because it's technology that we can use, but also we learn on how they operate to contaminate our internal culture at MFL. So before starting with the presentation, let me ask you a question. So let's try to do this interactive. Let's imagine that I know there are quite a few cable manufacturers in the room. So let's imagine that you receive a new machine at your plant, and you have to assign a weight to the value that you perceive of these assets. So 100% is the total value, and the value is divided in 3 categories. The machine itself, so how well it's built, the quality of the components, the craftsmanship, the precision of assembly. Second category are the services, any kind of services. So the services that you receive after the machine has been commissioned, or how well the manufacturer reacts when you need a spare part. And then the third one is software. So this event is focused on digital, on software, on the software part of our industry, about the wire and cable industry. So these are the 3 categories. What weight would you allocate to each one of the categories to reach 100%?
Machine quality, then the service, then the...
Assign a weight, like a percentage.
50, 30, 20.
50 machine,
Yeah.
30 services, and 20 software. Okay?
Because I think the software is a bit granted, no many developments have been done in it, so I care about the quality, then the service, and then granting that the machine is communicating well, so it's okay.
Okay.
That's how I see it.
Okay. And you are a cable manufacturer?
Fortunately, yeah.
Fortunately. All right. Okay, let me show you there's a lot of information in this slide, but let's focus on this part. So this is a paper published by McKinsey & Company in 2019. Has anybody seen this before? Anybody of you participated at the Interwire in Atlanta like 3 weeks ago? No? Yeah, that's good, because it was the same presentation. I just did a little update. Yeah. No, the topic was similar. So But so yeah, so let's focus here. This is published by McKinsey in 2019. The left bar is 1998. 80% of the value, of the perceived value when a cable manufacturer receives the asset, 80% was allocated to the machine itself, and then 20% split in two, services and software. Now we position ourselves in 2018, 2019 roughly, and the change is dramatic. 2/3 of the value are allocated to services and software. And just as I mentioned at the beginning, the services and the software part and the high-tech part are highly correlated, because with software we can service our customers, we can service cable manufacturers more efficiently. So it's not our analysis, it's an analysis by a very well-known consultant firm. The second message, before going into the tech part, this is a figure published in a paper written by two Polish authors. I'm not going to try to pronounce their names. And it's a paper that talks about how technology can help us with the lack of skilled workforce in the world. Which, as you can see, look at the thick blue line. That's the lack of skilled employees, the lack of skilled workers. And in 2016, it became the first risk for economic development in the world. Even higher than the prices of energy and raw materials, even higher than the economic policies, something that we are experiencing right now. Again, there was a little bit of a decline during the pandemic, but the trend is upwards. So that's one of the biggest, and I would say the biggest challenge that we have as machine manufacturers, as cable producers, and it's something where technology can help. Stop me if you have any questions. I mean, we're a small group, so let's try to make this interactive. Okay, let's start with the tech part. Let me introduce you to the MFLX ecosystem of applications. And on the upper left, we have Acumen, which is, I would say, the main application. It's an industrial IoT app that helps MFL Group understand how machines work in the real world, not in our plant, but at the customer's plant. And it also helps the customer make data-driven decisions for production. The second is Scout. It's an application that allows the customer, the cable manufacturer, rotate, manipulate the 3D model of the line, hide parts, hide groups, and select the spare part that they're looking for. And then it's just like an electronic, like an online shopping experience. They select what they want, and then they check out. Wizard, it's I would simplify it as a cloud-based calculator for wire drawing diagrams. So we have been doing wire drawing diagrams in Excel for, I don't know, for the last 25 years. And right now it's a cloud application where if I log in with the engineering profile, I can create a template. If I log in with the customer profile, I can access my machines and run simulations. And then you can ask us, okay, is this correct? And we validate the wire drawing diagram, and then you go. Emma is our generative AI co-pilot that we launched about 1.5 years ago. And we have been very busy training Emma with company knowledge, and she will eventually substitute or we will give, in addition to the static documentation that we give to customers, Emma will be there next to the machine to assist in anything that the operator might need, or anything that the production manager might need. And then the two on the bottom, they're just cloud applications that we use to configure the applications on the top without code, it's a low-code environment. Now, something very important is that none of these applications have been developed inside MFL Group. As I mentioned at the beginning, we invest in high-tech companies that are specialized and focused on these type of applications, and then we just use their technology to deploy it to the end customers. So today, we will forget about Scout, the 3D spare parts environment, and we will run a case study using these three applications. So again, Acumen, the one on the left, IoT, the one in the middle, generative AI, and the application for running simulations for wire drawing. And the problem that we're going to analyze today is this one. So can anybody tell me what this is? What type of production line? So it's a rod breakdown like for copper. And the case that we're going to analyze today is the following. We're going in with 8 millimeters, standard, right? We're going out with 1.59 millimeters. We're using the drawing line, the annealer, and we're taking up with the coiler. Now, so I'm going ahead and explaining what's wrong. So the production manager, the operators are observing the line, and they find out that motors 8 and 9 are operating with an over torque. So they're operating at more than 100% when the allowable torque should be not greater than 95%. The operator set up the line in order to skip capstan number 2, and the actual speed of the line is 24 meters per second. So this is the situation. From these three situations, or what is identified as problems, the one that we cannot accept is there are two motors operating at more than 100% torque. That could be a real problem if we don't correct the setup of the line. So we're gonna see one example of what the production manager should do. Let me stop this for a second to introduce so let's put ourselves in the shoes of a production manager, and we have at our disposal all these applications to observe the line. I already told you what the problem is, but the production manager still doesn't know, right? So he's going to use the technology to find out that there's a problem, and then to find out how to fix it. So we go ahead, we log into Acumen, we go to the smart notifications part, and if we are lucky, and if the production manager is smart, then this part of the application allows you to set up smart notifications, just like a phone. So the conditions here, for example, this one, it says that if the motor torque on block 8 goes above 95%, considering the mean value every hour, you will get a notification. But you have to program the notifications, right? You can program up to 50 if necessary, just like your phone. So if we are lucky, he did that. But so let's assume that he did it. He receives the notification. Oh, there's torque on motor 8 and torque on motor 9. And then he goes to the machine recorder, now that he knows that there's a problem, and he has to manually select the variables that he thinks are relevant to find out about the problem. So he goes here and selects for first the actual speed of the line, then he will select to monitor the torque of block 8 and block 9, and then for last he will select the outlet diameter that he's producing. But remember, I mean, we need a very computer savvy production manager to know how to play with these applications. The data is there, right? Then he will, plot the data, analyze it for 30 days, and then or for a day, and then he actually it was a little bit fast, but you can actually see that the motors are fluctuating between 105 and 110% of the allowable torque. Then he goes back to the ecosystem. I don't know if it was too fast, and then he opens the app called Emma and starts asking her, okay, what is the correct setup to run 1.59 millimeters? And Emma will respond with instructions. Let's give her a second. And then she tells us, okay, in order to run 1.59 millimeters of annealed copper, you have to do this. And I don't know if you notice at the very top, I'm going to go back. This is actually, the point number 1 is actually very relevant because she's giving me a link to Wizard, the simulations app, where I can actually see that. Look at block number 2. This is the theory, the correct theory of how you should set up the line to produce 1.59. And block number 2 is not being skipped; it's being used. The second thing that I would like you to notice, it was over here. Yeah, is that you can actually run at 40 meters per second, and the line is currently running at 24. Well, so you're losing productivity. So now Emma told the operator, the production manager, that there is something wrong with the setup of the line. And he goes back to Emma, continues the conversation, and tells her exactly that. I have the wrong setup. What should I do? It looks like I'm going to have to rethread the line again. Pull out the wire, and because you're skipping capstan number 2, right? You have to rethread the complete line. And he asks the question, and we let Emma respond. And you're going to notice something. She responds in a written form. And I have heard from many machine manufacturers in some special parts of the world that they have operators that do not know how to read. Right? So the production manager knows this, and so he asks Emma for videos because he knows that he has to, convey the message to the operators at the floor in a very clear way. So now Emma responds with a link to a set of videos that tells the operators step by step in a very visual form on what they should do to rethread the line. Okay, so a lot of we're using the complete ecosystem of apps to find the problem, and this is just going in loop, to find the problem and then to find the solution. But you need a very computer savvy guy that knows how to play and has the curiosity to play with digital applications. It's very, from after some years of deploying these applications, I have found out that some of the challenges is that, no offense here, is that a lot of production managers of certain age, they simply do not have the curiosity to play with these tools. So at the end, they depend on the manufacturer sometimes, or on their own experience, what they already know, to solve the problem. So let's turn the page. And up until now, I have not mentioned AI agents at all. I mentioned generative AI, but now we're going to turn the page and look further ahead, which is the main part of the presentation. So what are AI agents? So the big difference between an AI model, machine learning, generative AI, you have heard these terms a lot over the last years, is that AI agents are autonomous. That's the main difference. So let's think about an example in the consumer world. If you want to plan a trip, you could go to a travel agency and just describe to them what you need. I want to go to Greece this summer with my family, and we are 3, and I want to take my dog, and then the agent has to look manually for what are the hotels that are available, and he has to ask you a lot of questions to try to understand your what you like, what you don't like. Or you could go online and do the same thing by yourself, right? What agents are, there are some AI agents that are starting to emerge where you just go online and type what you need, just like if you were describing it to a travel agency, and then the AI agent will go and look at your social media profile to try to understand who are you, what you like, what are your past trips, and then autonomously propose to you 3 options to travel to Greece. And then you just click, okay, I like this one. Then he will go online and book everything for you on its own. And then at the end, in a matter of minutes, you have your complete vacation planned out. Let's take this to the industrial world. This analogy, let's take it to the industrial world. In the industrial world, or in our industry, in order to deploy AI agents, you need a data collection application, a data collection layer, which in our case is Acumen. Then you need down here, you need a generative AI application able to extract knowledge from a knowledge base, able to interpret your questions, and able to respond using natural language. And then you need a lot of APIs, application protocol interfaces, and connectors to other applications that are, in our case, are Wizard, the example that we saw before with wire drawing simulations, and Scout for the 3D models and spare part selection. So all these applications working together, they understand the problem, and then using GenAI, they respond to the user in a very natural way, proposing also the solution. So these are, in simple terms, what an AI agent could do. So let's go back to, let's keep our problem of the rod breakdown line running 2 motors at overtorque in our mind for a second. And let me introduce you the first little team of 5 EMA AI agents. So on the upper left, let me pause it here for a second. Okay. All right. So on the upper left, we have Fiava. Fiava is an agent specialized, and she dedicates 100% of her time to monitoring the health of every single motor in the line. Then we have Jacobo, which he's dedicated to ranking the best shift that is operating in that line. This is actually a very common question or a very common need of cable manufacturers. They would like to rank the operators, which is the best team operating the line over the period of 1 month, and some of these companies are using incentive models to give a price to these operators. So Jacobo is focused on only that. Tondini's is he's monitoring the overall equipment efficiency 100% of the time, and he will tell you why you are gaining points or dropping points in OEE. So this is all information that you can actually find using the applications. But you have a team of these little agents running on a regular basis and telling you the information instead of waiting for you to get it, to extract it from the application. Then you have Ivanko, who is constantly ranking the recipes that consume more energy, so you can make decisions. They might change from one month to the other, and you can make decisions. Maybe the recipe that consumes the most, you can run it during the night shift to be more efficient when the tariff is lower. And then the last one, Andros, he compares the scheduled operation of the line with the reality. Maybe the line was scheduled to run on a Sunday morning and nobody showed up, so he alerts how you should adapt your planning to the reality. Now let's go back to our problem and let's look at how Fiaba, the expert in monitoring the health of the motors, could solve the problem, find out about the problem and give us the solution. And it would look something like this. Inside Acumen, so the EMA interface disappears because, sorry, I got interrupted by my wife. Yeah, classic. No. No. She's not an AI agent. So let's go back here. So it would look something like this. This is the Acumen interface, so the IoT app. EMA disappears from the map. You do no longer need someone prompting a generative AI bot to get responses. It's invisible. There is simply a page with all the AI engines in this example, which is actually real. I had two, and this is the prompt that we give to Fiaba, and in the very bottom, we're telling her, okay, you have to do all this, and then you run every 2 hours, right? And then she goes into the data, and she pulls out all the health variables related to all the motors in the line, and if you can notice here that the perimeter of the agent is red. That's when she's not happy. That's actually she found a problem. So if you imagine having 25 agents around, you would see so a group of them are happy and others are not, and then you can dig. You can understand why, right? So let's go on with the video. Here, this is a dedicated page where you can see, okay, tell me what Fiaba found out during the last 30 days, 6 months, whatever you want. I mean, the data is all in the cloud, so you can go back in time. This is actually an older version. In the new version that we have, all the events are like packed in a little box, so you can expand them. And on the main page, you can execute the agent manually as well, instead of waiting for the 2 hours to go by. And in the main page of every single agent, you have what she found out. So she found out that motors on block number 8 and 9 were operating at over torque. She found out that that we were skipping capstan number 2 instead of setting up the line according to the theory. She found out that we were actually running slower that the theory allows to run. So she found out all these differences, and then next section is she will recommend, and you find some similarities to what Emma responded to what Fiaba is telling us, right? And then at the end, at the beginning, we have the same link to Wizard, where we saw theoretical setup of the line, and at the end we have the same link to the videos. But the message that I want to leave is that there is the only difference is that the agents are operating autonomously. They are telling us the information. Okay. And I think that's it. I open for questions. If you didn't interrupt me, but I'm sure you have questions.
I went to the 70-30 now, not 50-50. I changed my mind
after this.
About data collection, is that collected in your servers or the customers? Do you have some agreements?
Yeah. So the data flows from the PLC to an edge computer, and then to the cloud. Our applications are all of them are on Microsoft Azure, and we deploy these services as a service, right? So the data at the end is in our tenant, in our Microsoft tenant, but it's property of the end customer.
But you told that at the same time you get information on how your machines runs in the factory.
Yeah.
So you do use it internally as well.
We use it internally as well, yes, because what we have proven over and over is just, forget about the agents for a while, only IoT, only Acumen. Whenever a customer contacts us with an issue, we can pinpoint the problem a lot faster and a lot more because we are connected. I mean, Acumen is the main application because it bridges the gap between the end user of the machine and the manufacturer. It brings us closer together. Yeah. Of course, there is a contract that basically says that we can use, what we observe from the machine, we can use it to help the customer, or to for product development. So those are the two main. Of course, we cannot use it to, give the data to the competitor of that.
But you better machines that you might sell for competition.
Oh, security?
Yeah, and I was thinking about do some companies have issues with that you use data that you gather there to produce better machines that you sell for the competitors?
No, but that's that's very well regulated in the agreement, which is it's very clearly written that and actually we have been doing this for 5 years now, and the main concern right now, so that concern is slightly disappearing.
That's good.
Over the last. So we have been doing IoT for 5 years, but before we were already connecting lines just to troubleshoot. No data collection, just regular. You go into the PLC and fix something. And at the time, 10 years ago, 15 years ago, the first thing that the customer would do is just unplug the cable. When we were done with the commissioning, they would unplug the cable, and then you were completely blind. Now with constant data collection, it's even now we can actually see what they do, right? But that concern is slightly disappearing. Right now, it's all about cybersecurity, which I completely agree. That should be the main concern. The complete architecture has to be sound in order to comply with against any cyber attacks, and that is completely understandable, and we're making sure that happens.
So your question is answered. My question is, I was at your show at the Düsseldorf fair. That's a little bit more than a year ago, I guess.
Yeah. Yeah.
And I'm impressed because I expected kind of the similar story, but you made good progress. So my question is, where are you in next year or 2 years from now? What's your roadmap? What is the next great thing?
Yeah. So we are going fast, not because MFL Group is fast, but because the technology companies where we invest are fast, right? It's a way to to contaminate ourselves, because I mean we are a 128-year company, right? You cannot turn around the culture like this. It's a process. Where do we see ourselves in the future? Well, AI agents is something new, right? 2 years ago in Dusseldorf, no, it was last year, right? Yeah, last year. Last year we presented generative AI. We presented Emma. It was the whole show was centered around Emma, how you could use, similar to the first example that I showed. It's another case. It's another case study, but similar. And that was it, because generative AI became possible for everybody in November 2022, right? With the launch of ChatGPT and all that. So that was the thing 1 year ago. Now AI agents, it's a trend that started to become public or more of a hype, more or less in November, December of last year. And these are the agents were actually launched during the same week of the Interwire in Atlanta by our tech company, by 40 Factory. They launched it at the SPS in Italy. SPS drives an exhibition during the same week that I explained it in Atlanta. So that is something new. What we have right now are examples that actually are working examples, but in 2026, 2027, that has to become a reality. Yeah.
Andrea, when do you expect to apply this to the process itself and the production parameters to let the machine adjust itself automatically?
Yeah, I would say that's a future step.
Huh?
Yeah, I don't want to. I don't want to promise any timing, but that's the logical next step. Yeah.
And you have to add some more paragraphs to your contract.
Yeah, before making something explode. Yeah.
You can expect this in terms of 2-3 years to be practical on the ground with the shop floor?
Yeah.
Or more?
No. I would say that's a reasonable target. Yeah.
With the pace of the life cycle of these progresses and inventions, I think 2-3 years.
Yes. I would think that's a reasonable timeline. There are a million of examples. Just a few weeks ago, we were, I was observing how an operator tweaks the valves on an annealer, just to control the oxidation of the copper wire at the exit of the annealer, and it's a manual process. You need a lot of. If you have a good operator, then he will have it done. If you have rookies, like, which is the main problem that we have, then you need some guidance, and that the guidance it will be done with AI. I'm pretty sure about that.
Extrusions with all these problems.
Extrusions, yeah.
This will turn it real automated process.
Yeah, imagine all the temperature zones in an extruder. It's yeah.
And it will be easily to handle it within the data available in the plant, so we can transform it. Yeah, and it's not necessarily to do on a brand new one or a greenfield one.
Yeah.
We can change the old one.
Yeah, exactly. Yeah, I mean, depending on the machine. Sometimes we get requests to connect machines from 20 years ago, and everything is possible, but then the quality of the data that you extract from these old machines is limited, because
It's stable business at the end that we have 20 years machine flows.
Yeah.
Everyone has it.
Yeah. Where are you from?
We have to live with it.
Where are you from?
I'm from Sweden, in Egypt.
Okay.
So I've been suffering 8 years to transform only the data. Yani just to be ready for this step.
Yeah. We're doing some commissionings there, right?
No, we have a side talking.
Some difficult commissionings, yeah.
Those tech companies that develop those products, they are only for your users? Or
No,
they,
no, no.
They sell it?
No. The investment thesis is the complete opposite. We invest in these startups, and some of them are already like growing, not to use them for ourselves only, but to learn. Like, for example, the developer of the IoT app is a Forti factory in Italy. We are only one of 70 manufacturers using the technology, and the other manufacturers are are involved in other industries, packaging, industrial filtration systems, pharmaceutical, food and beverage, and we learn from what other industries are doing. For example, the packaging industry is more advanced than the wire and cable industry. There are more robotics involved. They are more sensitive to these types of technologies. So we're learning from what end users are requesting in those industries to try to apply something that might be compatible with the wire and cable industry. We invested in another startup recently based in Switzerland for computer vision systems, and the applications there are endless.